Welcome to the TESTPILOT Podcast, your source for in-depth bike tech. My name is Jens, and in this episode I will speak with Dave Weagle. We wanted an easy start, talk about his engineering background and things like Antisquat, but it escalated quickly and we took a deep dive into the rabbit hole. So we talked about the complexity of ride dynamics, how misleading geometry tables are, which problems linkage forks could solve, and a few things more. So bike nerds out there, this podcast is for you. Nice to have you on. Actually, it's the first episode now. I'm glad to have you on this podcast because I think you're one of the more important persons of the bike industry in regards of understanding the technical side of things and having an approach towards mechanical engineering in bicycles, which
that's very kind of you, and thank you. That's it's high praise. I mean, just trying to put one foot in front of the other, buddy. Learn every day.
So, for those who actually don't know you, how would you describe yourself in a party with bikers? What are you doing?
Well, I would say, to start off, I have never felt defined as a mountain biker or I define bikes. Bikes don't define me. I didn't grow up working in a bike shop. I didn't grow up wanting to, work in the bike industry my whole, my career, or start a career in the bike industry. I knew nothing about it. I was into motorsport, and that was my focus. That's what I wanted to do for my life. And I kind of just fell into racing mountain bikes. I fell into racing dual slalom. And, one thing kind of led to another. There were just issues with the products I was racing and just decided to fix them for myself. And then one thing kind of led to another, I'd say that mountain biking is one thing among a large group of things that I'm interested in and do. And I find it incredible, upon reflection, I find it quite incredible, the impact that the work that I've done has had on the sport and on the industry and just how things have changed. But it's never been necessarily premeditated. It's just kind of happened organically.
So your wisdom is not only coming from racing, you have an education in that segment.
Correct. Yes. Yeah. I went to school for mechanical engineering, just a bachelor's degree. But I was focused my schooling on, I wanted to work in Formula One. Without going into great detail on the story, ultimately I met my now wife of 20 something years and then decided I did not want to pursue going to England and, following the path of being an F1, having done a bunch of due diligence on that. And so the only thing I was really qualified for was working for some advanced R&D capacity. So I got a job working for the Department of Defense, and then kind of one thing led to another from there. Ultimately, my buddies that I worked with were all into mountain bikes and got me into it. And I couldn't fit I would have bought a motocross bike, but I just couldn't have fit it in my apartment, which was literally too large. It was on the 5th floor. I couldn't get up the stairs. There was no way. So my first job, my first real paycheck, I bought a mountain bike to go riding with my buddies and started racing. And just kind of, like I said, that's the story. Just kind of went from there. So yeah, I've had that mechanical engineering, an engineering approach, but I would also say that I have really been driven my whole life to learn things that I don't understand and try to approach things from the mindset that I don't understand what's happening and I don't understand the problem fully, and try to find the nuance of the problem and really get to the bottom of, what's happening. And for me, that process is simplification. Simplify everything as much as I can and then build it back up with, the understanding of the more simple parts of it. And, it served me well. So I think that's really kind of how I ended up in the bike stuff,
It's kind of the Formula One, but in cycling, because you managed to gather a couple of titles over the years on racers using your systems plural, because it's not only one, right? How many different suspension how many different suspension versions, kinematics you developed over the years?
I think there's been 5 completely unique, distinct designs that I've put up that have been on World Cup podiums that I've developed. which is crazy to think of, but I think that's the reality of it. That's wild to consider. But, again, I think it comes down to the process. It comes down to I was for sure one of the very, very first people in cycling to run any amount of data acquisition, built my own data acquisition systems back in the late 90s, early 2000s, and started measuring from there, which was super helpful because, being able to characterize a problem, and keep in mind back then, we were talking about 3 rings on trail bikes, triple rings. And in some ways that was quite a tidy, it sounds like it could be more complicated. And in some ways it is, but it actually is quite a tidy way to solve some other problems that come up when you put a human on a bike and try to make them climb a hill and go down a hill and all on the same thing. So, I learned a lot from those experiences early on. And I was super lucky to work with some amazing, amazing riders. I mean, just lucky to meet top level people right out of the gate, right when I started working in bikes, and be able to talk to them and pick their brain and learn from them. And, like a good example, the first like top flight rider that I really worked with was Nathan Rennie, and who was an absolute animal of a rider. And especially he was almost peerless in the time, like in terms of how he rode the bike. And so I remember watching him ride his Yeti, like, and knowing that he was coming onto our team the next year and just thinking like, holy shit, like, how are we gonna do this? What are we gonna do? How do we keep the bike in one piece? Like, what do we do here?
Do we need to put it in perspective? He's 6'3" and 220 pounds, maybe.
Oh, purely ripped. Just an absolute monster. Like, yeah. And yeah, it was just, I learned a lot from him and how he rode and how he approached things, and just kind of trying to not screw it up for him, basically. It's really the bottom line.
I think, like, I was referencing his weight.
Mm-hmm.
And weight, now we're dipping right away into physics. And you can't trick those. You got to work with them.
Yeah.
Means, like, if a 220-pound rider is hitting a berm or landing a gap or overshooting a jump or whatever, he's generating force.
Yeah.
And Rennie is like, or had been, like, an absolute legend on hitting stuff hard.
Oh yeah, yeah, for sure. Yeah, there's so many stories like that, right? Of things that he accomplished on bikes and things that he just stuff that he hit so hard that nobody thought could be done, would be done, just in the course of a race weekend, let alone like in a off the race weekend. So yeah, it was incredible. I think it's just dumb stuff like. There's so many things that like we did back then that are just completely lost to history. Like 1.5, oversized headsets. Like that did not freaking exist before I got involved. I literally had to make headsets. I remember one of the head guys at Cane Creek. I love this dude. And I'm not going to name him by name, but he told me, he's like, this will never take off. Like this is not even, it's completely stupid. There's no reason. We never need a 1.5 headset on an integrated, 1.5 headset on a downhill bike. It's ridiculous. Never need this. And I was like, screw it. I'm building a 1.5 headset on all the bikes we build. I don't even care. Literally built the first production 1.5 headset bike. And that was only because the previous prototype that I built had basically a super thick aluminum head tube with a steel insert. And then the headset went into the steel insert just so we wouldn't ovalize the head tubes. And then that was on the very first prototype Evil Imperials. And we ovalized it. And I was like, oh shit. And then somebody, I think it was the Manitou guys or somebody because they were building the 1.5 head tube, and they came up with this headset, and it was only like a couple millimeters off. And I'm like, screw it. I'm just going to bore this thing out and run it. Like whatever. It can't be worse, And, one thing kind of led to another, but stuff like that we just was almost a necessity for a guy like Rennie. Like, dudes were tearing head tubes off all the time. Tearing the headset right out of it. And think of how many times you ovalized a head tube. You must have, dude, you're a huge dude. You must have ovalized head tubes like crazy.
Yeah, ripping off and building cracks and stuff. It was part of the game, but that's 24 years back.
Yeah.
But as you said, if you have a 1.5 head tube, what are the benefits from a mechanical standpoint? You have more overlap.
Yeah, it's just literally more area. It's so simple. It's so simple. It's literally more area. That's why I made the steel insert, previous to that. It's just literally just, I mean, this isn't advanced mathematics. Like, it's just straight up area. Like, you need, the material has a finite amount of stress that it can handle. I mean, the only way you get more strength out of it is add more contact area. Pretty easy.
So before we now maybe take this forces and weight topics into kinematics, we need to understand one thing. And correct me if I'm wrong, but we could say you somewhat named or found a name for a principle, which Newton's law, in which a mass will always want to stay at the rested position, or if you move it, it wants to keep moving.
Sure.
I'm referring to Antisquat.
Yep.
So, in a nutshell, you could explain it like the mass is the rider.
Yep. Yeah, rider and the sum of the bike. Yeah.
And then you put in force, and the bike is moving forward. So, could you explain in try to simple terms for the people who are not 100% aware of what anti-squat is about?
Sure. Yeah. I mean, anti-squat is a pretty, I would say, in automotive parlance, anti-squat was one of those things that, people, you learn about in automotive suspension design, that which was my background. That's what I wanted to do. And, was really studied in that at that point in my life. And it's a suspension force that is an internal chassis force that is, I would say, was understood, but not really used to great effect or to great, it's a bit harder to manipulate it in an automotive suspension just because of the way that the suspensions work outside of a four link and drag racing and stuff where they did a good bit of that, but all empirically. And for whatever reason, this is going to give a little bit of, I'm going to bring this to the simple part of it, but I just want to give a little bit of the history of it because it's kind of incredible to me the way that it all worked out. For whatever reason, people decided that they, in automotive, they were going to calculate this geometrically. And what I mean is they were going to draw a bunch of lines, geometric lines, and they were going to kind of figure out what the anti-squat was or what their roll centers were when you're talking about cornering and stuff. This has all been completely debunked. But 25 years ago, that was the state of the art. And I would say some of that geometric roll center stuff or geometric, calculation does work under a half a G, and get you a pretty good approximation of where you're at. But when you start talking about race cars, especially cars like a Formula 1 car pulling 4 Gs or something like that, 6 Gs, that stuff's completely out the window. This no longer characterizes the problem. Or no longer characterizes the solution to the problem, I should say. So with that, I saw that there was a real opportunity for me as I started kind of doing the math on this. I realized there was an opportunity to not only understand it better for me, but to apply it. So anti-squat's real simple. If you think about it, I can give you a good analogy. So like you said, every action has an equal and opposite reaction. A body in motion tends to stay in motion. Body at rest tends to stay at rest, right? So you're on your bike, you got your center of gravity, you got your rear wheel here, you move forward. This thing doesn't want to move. Where you're pushing forward, and something's got to happen. Something's got to give. So if you think about it, if you ride a wheelie, weight transfer is the key component here to understand. If you're riding a wheelie, you go from, say, 60% of your weight on the rear wheel to 100% of your weight on the rear wheel, right? You're doing endo, all that weight transfers to the front. You're all the way. Go from 100% on the rear to 100% on the front, right? This happens whether you're riding a hardtail, a fully rigid bike, a full suspension bike, it doesn't matter. So if you think about that same thing on a hardtail when you ride a wheelie, right? Well, that weight transfer happens. It just happens instantly, basically. It happens super quick. Well, on a suspension bike, the more suspension travel you have, the longer the delay between how much your mass, just literally in time, how quickly that's going to load up the rear wheel, because you have compliance and the spring is taking up energy and your weight is shifting rearward more slowly. So all anti-squat is an internal chassis force that counteracts that weight transfer. And I think people get, there's been a lot of creative marketing over the years where people are trying to come up with, ways to market against, somehow market against anti-squat, or like say, we made a product that's so much better because our anti-squat has like less pedal feedback or something. Like, that's asinine. None of that's accurate. None of that's true. It's just completely made up, contrived. It's just a simple internal chassis force. When you balance it out, if you balance it out perfectly, which you never can, because, people are it's a person, they have a different center of gravity height, our, torso is a different length, everything's freaking different. But let's just say somehow miraculously you are perfectly evened out, then your suspension would be completely free to move, the most compliant possible. There's no better number than nothing better than 100. Granted, it's impossible to achieve. You never get there. But it's so funny to read stuff like, oh yeah, no, we reduced the anti-squat amount so that we can get it to climb better. I'm like, okay, yeah, that completely makes sense. Like, it's impossible. It's just, but I think sometimes these things, like, they're so simple that they become difficult to understand. And I mean, it really is that simple. And I mean, that's really it. And that's all it is. It's just a simple force, one of many. And it's not, I think of like building a suspension or a bike or anything, a product is like baking a cake. You have all kinds of different ingredients, and you can make a pretty good cake with 20 different ways, and you can make a gluten-free cake that's pretty good, just surprisingly, you can make like, it doesn't hunt for a story. You'd think like, man, how the hell do you make a cake that tastes any good? How does it even stay together? It's got no gluten. You can do it. It's pretty good. Adam. So, whatever.
So talking about balancing forces, and we were talking already about Rennie, but anti-squat is maybe the thing that you kind of discovered into bikes and figured out a way to deal with it, to produce or control somewhat the counterforce, to actually make bikes not pedal like a bag of sand.
Exactly.
And going back to Rennie, like a 220 pound, he would potentially be heavier.
Yeah.
Anyway, but I remember we had a call a couple of years back, and I was stunned by the performance of the back then robot bikes. It's now Atherton, at a DW6. And I was hitting corners on this bike, and I was like, dude, this is just, it's not squatting under like 1 second of pressure under my weight in a berm. There gotta be something with the shock. It was back then a RockShox Monarch Plus, which wasn't a shock known for a lot of abilities, to say so. Development of shocks got better, but this shock, I would assume it has a special tune. It was packed with volume spacer. Neither of this was true.
Yeah.
It was completely empty. It had a regular medium tune, and still I could hit a berm and the bike wouldn't bottom out, even though I would run like 25% of sag. While other bikes, you're setting up with the same amount of sag, you would hit the berm, they would squat way more. So coming back to forces, how could you explain that? How you counter this force in the kinematics?
Well, like I said, all the ingredients to make a cake, it's not just anti-squat, it's not just, anti-squat doesn't have, the beauty of, let's back up to anti-squat. The beauty of the mechanical solution for using anti-squat versus, say, using an electronically controlled compression valve, like live valve or flight attendant, or whatever you want to call them, like, as soon as you stop pedaling, anti-squat's off. It's gone. It's no longer there. The system is completely, it only balances out the acceleration, the weight transfer forces when you're physically pushing on the pedals. That's it, which is, you can't really do better than that. You could equal it with some electronic controls, but you can't do better. But that frees you up from, and I'll say, like, talking about baking the cake. What you're doing with a leverage ratio, what you're doing with, and people, I think, miss the point of what we're trying to achieve a lot of times with how we're manipulating that damper and how we're manipulating that spring. What you're doing with your chassis stiffness, that's very, very prescribed and highly tested. And how they all work together. And it's not just the back of the bike, it's how the front of the bike flexes, how everything moves together. I think it's really just the entirety of the package, and how it all, and it's always a compromise, like these companies that are saying, oh yeah, no, we got no compromises. This is the greatest thing ever. It's impossible. It's the best in every way. Okay. I mean, come on. Like everything's a freaking compromise. Like what you do go in one direction is going to hurt you somewhere else almost always. So finding that kind of balance that, makes the cake taste good, right? That's really it. And I'd say it's probably, kind of going back to your earlier, question or whatever we're talking about, putting different designs on World Cup podiums. Like that same process, you can yield a similar result in different ways, even though the way that you're getting there is completely freaking different.
To put it in simple words, and using the robot or Atherton example, is like this: the compromise, the cake you built on that bike was something that could manage forces applied, which are X in a berm, would result in a behavior of the bike to this amount of squatting or like compression into the bike. And what I really find interesting is that you developed over the years different kinds of suspension designs, like DW4, DW6, split pivot, delta. And having the opportunity to have ridden pretty much all of them, I could say that all of them have their very specific characteristics, which helped to shape the bike, how the character of the bike is. And if you're riding a pivot, or if you're riding an Evil, or if you're riding an Atherton, it aims towards a specific kind of riding style or rider profile. Yes. And this is something, it's not easy to explain, because if you go into a bike shop and say, I want a bike, you maybe saw some video marketing, you saw some advertisement, and you're down to buying a pivot or an Evil or whatsoever. But it's so hard to explain that the different suspension kinematics result in a different riding, and sometimes it's a match and sometimes it isn't.
Correct. I think the reality, I've certainly developed products, I have different levels of control over, the entire package for different brands that I work with, right? And I would say that I have certainly pushed all of the brands that I work with in a direction of like the things that I like out of a product and how they feel and what that certainly rewarding more aggressive riding. Anybody who knows me and rides with me, like I'm not like a guy going out to earn my turns. Like I don't really care about climbing up some huge hill. Like whatever, that's irrelevant to me. Like it does nothing for me personally. Like I just don't get the like endorphin rush from climbing some 7,000 foot hill. Like to me, it just sucks. And I don't want to do it.
Use a hardtail then, if you're into that one.
I just want to go rip turns and hit jumps and stuff and pop off ellipse on the side of the trail and find some stump to nose bonk or whatever, like that's the stuff that I enjoy. So I have definitely like built, gravitated towards and built products to kind of be able to take on that type of riding. And I'll say that there are, as I've gotten older for sure, I can't, nearly ride the way that I used to. I'm just too old and too broken. And I can appreciate that the type of riding that I've enjoyed and gravitated to is certainly not the most prevalent type of riding in the industry. Like, for sure, there are a lot of people who like to sit in the saddle and pedal through everything and never get up out and, just are going to kind of plod along and probably want some, can benefit from or enjoy some more mid-stroke, less mid-stroke support, like just kind of let it be more of a noodle, but then when you go into a corner, you've got nothing. You've got no support. Like you can't hit a corner. Like your bike just gets choppered out. You have no steering all of a sudden. Your front end's washing out. You're way too far over the back of the bike and you can't even get your bars are too far back. Like you're completely set up in the wrong body position. And I think that's one of the really critical things. I know for a fact that I look at bike geometry very, very differently than anybody I work with. And it is a constant discussion. Like I'm speaking in completely different metrics, a completely different language than anybody that I actually work with.
What would be an example for that?
Well, everything. Mechanical trail versus head angle. Not even ground trail. I don't even look at ground trail's fine, cool to look at, but it changes. It's not a real metric. Can't really directly. You can't apples to apples change ground trail. It doesn't work that way. Mechanical trail you can. I find it laughable that the bike industry uses reach still. I find it ridiculous that we talk about geometry completely unladen. Like just literally the bike is standing off the ground. It's levitated with its own weight, suspended somehow by a magical force. And that's the bike geometry you're going to decide to purchase on. And it's just the stuff. It's insane to me. Like, none of that stuff's real. That's why when you ride two bikes that seem to have the same geometry and you put them on the trail and they're like completely different product, you're like, what's going on? I'll use like a good example. Like I was working on an e-bike recently, a longer travel e-bike, and the bottom, if you look at, the company that I'm working with was like, what's the bottom bracket height? And I told them and they were like, that seems way too high. And I'm like, yeah, I mean, if you're looking at it like on levitating off the ground, like, yeah, probably. But when you put it on the ground, like actually start measuring what's happening, like when you're riding it, like it might be low. And it's just so funny. Like
maybe the best example also for that is like seat angles in the last couple of years, which became a thing. And people now actually want to see an 80-degree seat angle. And even the media is asking for that. But they don't put into consideration that maybe a trail bike with 120 mil of travel versus a 180 or 160 whatsoever, dynamically wise, it's a different story where you're actually sitting.
100%. And seat angle is one of the most asinine measurements ever conceived. Maybe second to virtual top tubes, but pretty darn close. Like, seat angles and virtual top tubes, I mean, I can see why they make sense for road bikes because they haven't changed in 150 years and, whatever. Humans haven't changed that much. So, yeah, you could probably look at road bikes and be like, yeah, okay, here's my seat angle, here's my head angle, here's my virtual top tube, and I can sort of fit a human to this thing with these numbers. But we're talking about mountain bikes, like you said. When you're talking about different forks that have different amounts of stiction, like, that just have huge effects on what the bike is actually doing when you're riding it.
A couple of years back, I built a prototype bike with pushing the limits of geometry.
I remember.
And the thing is, to understand geometry better, I was reducing the travel and not want to go overboard because the change, if you put in a 62 point whatever head angle and you compress the wheel is traveling backwards, shortening your wheelbase.
A lot.
And then your rear end is coming forward. In the end, the balance between the two axles or contact patches interacting with your center of mass is highly dynamic.
Yep.
So if you want to understand geometry and adapt to a geometry, because this is what we're doing as humans, we are adapting to a tool. And because we are learning how to ride a bike and we're building muscle memory, we're getting used to something which feels, let's say, normal, or we are used to. And then eventually, while bikes grew and geometry changed, we had to adapt our riding style.
Yes.
And something that might be better suited on the trail feels odd because our muscle memory is used to something else. Yes.
It's real. 100. I mean, this is one of the biggest challenges for the Trust product was literally that exact thing.
Yeah.
It was so alien and so different. And some people, it's funny, some people, humans in general, are just wildly impressive, and some humans can just instantly go and, ride a backwards bike or, shoot a basketball with a left hand versus a right hand. And some humans, it's impossible. It will never, ever freaking happen. And I would say by and large, we're in the latter, it's like once you learn something, it's so hard to break that pattern for most people. And I mean, I've learned about myself, for sure I'm in the former category. Like I can switch my brain either way. It doesn't matter. I can, somewhat ambidextrous. Like I could throw a baseball pretty well, both arms, like stuff like that. Like can ride a backwards bike, but not everybody can do that. And it's, boy, it's so hard to change that muscle memory and really like in real time think about what you're doing. It's so hard.
Also interesting is, and I want to keep in mind to go to the Trust Fork because this is a super interesting product. But one thing that really baffled me over the years is when I tested bikes, I can switch bikes and I can talk to a different test rider, maybe the same height, maybe the same weight, but still I can change or switch my body with this person. So I'm stuck into what this person, myself, knows about riding a bike. I'm dealing with a certain way of how my muscle function, how I'm processing data, aka trail, on what I'm riding and interacting with, and maybe some other person can't see that good, or hasn't have the quick reaction time, or is stressed out by a wet route because they never rode something like that before. And they're making a mistake because they're getting like distracted. And then what we are always do as humans, we're using language to explain what we feel, but still it's just never the same as we would experience if we would be able to switch our bodies. And
totally.
It's the same with weight. And if I'm a little bit lighter now, but still, like I'm putting in forces into the system, into tires, into wheels, in a complete system, as you say. And I'm interacting with that system. You mentioned cars earlier, but a car is like, I don't know, 2 tons.
Yeah.
It doesn't matter, like, what you're doing. If you bounce up, you can't bunny hop a car, right?
Exactly.
No, but you're interacting with something. So now we're getting to complexity of a center of mass being somewhere in a virtual room, which is changing to a system that is changing geometry. And now we are deep down in the rabbit hole of talking about the system and trying to explain to somebody how this bike is riding via a geometry numbered table.
It's impossible.
That's impossible, yeah.
I mean, the thing is, too, right, Jens, it's changing in 3 directions, your center of gravity location, right? Yeah. 3 axes, and the bike is flexing in 3 axes. Oh, more than 3 axes. It's flexing everywhere. The front fork, I mean, it's crazy. It's crazy to consider the reality of how much telescopic front forks flex. Like, it's stunning when you actually see when you actually measure the real numbers. I mean, 60, 70 millimeters, no big deal. It's pretty much normal. You know, you're talking about your contact patch moving around, right? Like, when you got fork is moving back and forth this much, I mean, like, that's pretty darn hard to deal with, no matter who you are.
Yeah. And then you came up with the Trust Fork.
Yep.
So, in a nutshell, this thing changes trail.
Yep.
So, the interesting part is that we humans, not only we're getting used to muscle memory or stuff we understand, and we say, this is our truth, this is the only truth, and we start to avoid any change. This is just human nature. So, unless you are curious and you're kind of a scientist.
Yeah, I would say by and large you're correct. And I would say also, you know, to on top of that, like, and perhaps this is part of the marketing side of cycling and how the people that it's brought in, but I'd say by and large people in mountain biking, you know, have are bought into and are interested in a lifestyle, and like are maybe they see the downhillers and the enduro guys, and they see all that stuff and they're like, I want to do that. I mean, who doesn't? It looks amazing, right? And it is amazing. Sure. But how many people are really doing it, dude? You know that. Like, we're out on I mean, how many media launches have you gone to in your life? Like, I mean, guys are hardly even getting down the hill, let alone like being able to test the bike. I find it like insanely laughable that people are trying to test World Cup downhill bikes and give an honest opinion. Like, I can't ride that thing. Like, there's like 20 dudes in the freaking world who can ride that thing. Like,
and there had been an episode, what was it called, Top Gear, where Hammond tried to drive a Formula One car.
Yeah, exactly. I remember that. Yeah, I do.
Insane. And he started Formula 3, 4, whatever, working himself up, and he couldn't get it out of the starting gate.
Exactly.
And when he could get it out of the starting gate, he wasn't going fast enough to produce enough downforce to make the tires heat up, to generate grip, to go around the corner. And he wouldn't brake hard enough to heat up the brakes. So he was completely struggling to actually make it function. So
it's just,
Formula One in cycling, talking downhill bikes, it's like we're building a bike that is working for the best riders, the best athletes, and I had to underscore that because they are on a physical side of things, they are on a completely different level.
100%. They're unbelievable. Every one of them is.
Yeah, and they can make it work. And
yes.
Even though there are insanely talented people out there, and looking back 20 years ago, like first backflip on a mountain bike, going faster, you would be like mind blown. And young kids now are going insanely fast, but still, like there's like a gap. Like in World Cup, the top 10 guys, it's just different. And if you have never seen those guys riding it, and girls as well, I mean, they would kick my ass.
Oh, every one of them, every single person.
And it looks,
it's like the bell curve, right? That 99th percentile is just freaking straight up, Like the difference between 99.1 and 99.8 is like, it's massive. It's a giant, giant gap.
And if you never had the chance to actually stand right next to a racetrack.
Yeah, exactly.
Or I had the opportunity to ride with the Edmonds. And you're going flat out, flat out as fast as you can. You're on the edge of crashing. You don't think that this can actually work. And Dan Atherton or Rachel is behind you on an enduro bike. And you hear the rattling and you think, I'm going so fast. And these they're just riding one-handed.
Taking a cruiser.
Yeah, they're taking a cruise. And it's so hard for people to understand how different the forces are that these people put into the product.
Truth. Yeah, and I mean, they're just, the riders, it's just constantly impressive and amazing to me what humans can do. I mean, especially people at the top level of any sport, it doesn't matter what you're doing, water polo to baseball, the World Cup downhill to World Rally, amazing, just abilities. It's amazing. It's incredible to celebrate. And I love it. I love just being able to work with athletes like that and help them achieve their goals. And, and everyone is kind of built differently. So trying to helping them understand what they do well and where they need help and trying to help them in the places they need they need help. Right. It's pretty darn cool. But in the end, it's up to them. It's 90% them.
But circling back to the thrust fork, because I think this is a very special beast of a product. Because we just said it's changing trail, and by these characteristics, and we got used to something like that looks like linear fork, what we could say linear fork.
Yeah, telescopic.
But we have kinematics as well at the rear end of the bike, and you put kinematics in the front of the bike, and by doing so, you achieved you open up the possibility to make the suspension behave differently. And even for average Joe riders, this was noticeable.
Yeah, anybody can. I mean, I wish that that company had gotten to the point where we could have found the right rider to race World Enduro on that, to race Enduro on that product, because on a stopwatch, it was unbeatable. Like on a actual race, I don't care about you're talking about, doing some 30-foot hucks to flat. Okay, that's quantifiable stuff. That's different. That's just, but I mean, some of the times when we started actually testing just with the stopwatch, I mean, you don't believe the numbers when you get to the bottom of the hill. We're talking, 20 seconds difference in a 6-minute race, a 6-minute segment. That's crazy. But there's only a small group of people who could really change themselves to go and do it. And I would say that product was developed to do something very specific, which was to increase and normalize mechanical trail on the front of the bike.
Sounds
on top of that, reduce
But
flop
what-
factor. So it had precise steering. It didn't really have that flop, and it had a bunch of trail, and it needed to bolt onto a standard bike, not just be some kind of super integrated thing. And there were some reasons,
which we
flex
have in the
reasons.
market.
Yes,
Which
and it's hard. It's easy to build a fully integrated system like that, but it's hard to make them flex. The problem is we really screwed up the flex on that product. Like those forks did not. From a composites design standpoint, we had basically just before the company went out of business, we had just gotten to the point where we had a working laminate that was providing the flex that we wanted. We knew what we wanted from the very beginning. From 2015 on, we knew where we wanted to be. We just never could physically achieve it based on some early mistakes that were made in the laminate development that we couldn't overcome. And some major delays internally on just the structural side of things. We just couldn't really do the work that we needed to. And the bottom line is those forks just did not have the fore-aft flex that they needed to. They were just way too stiff.
And also, if you would like land rear wheel heavy, you could get some vibration.
That's exactly the problem. Yeah. We knew what we needed to do there, just couldn't achieve it from a flex standpoint. People always, you'll read the armchair engineers on the internet and they're like, oh yeah, no, the axle's moving back, like whatever. I'm like, yeah, dude, it's irrelevant. It's like half the distance that the flex would happen. Like in the zone that you feel it, it's not even, if a telescopic fork is flexing 70 millimeters fore aft, for that same load, we were flexing 5. Like, it's just, it's a pretty simple problem.
It's still working at that point. It's not like you get some binding.
We had a lot less stiction, so that makes a big difference. But when on a telescopic fork, you have, if you're talking like on your low speed side of things, maybe half of your force is low speed damping and half is stiction.
But
on the thrust
damping,
fork,
therefore.
Yeah. Damping and stiction are like equal when you really measure it in reality, which is incredible to think of because stiction is just this variable freaking spiky force. It's just kind of in and out. And on top of that, you don't have a leverage ratio in a telescopic fork. They're not really as pressurized. You have a lot more hysteresis in the dampers. So you have, it's funny. Like people would always be like, oh, the trust fork, it has so much damping. I'm like, it doesn't, it has less damping. It actually has comparatively, like if you're going equal 1-to-1, like it has less damping, but it had so little hysteresis that it had more often. So like had it more often. And so like, it's incredible. But in the end, like the later stuff that we're working on, we're literally trying to introduce hysteresis into the damper, which is crazy to think of. And like, pains me to say that, but we were like, yeah, we got to add hysteresis into this thing. It's incredible.
I was back then. I was from riding and how controllable the fork was. I was blown away.
Yeah,
I was really blown away, and I think, yeah, we have trends. We're selling bikes on the color, on the looks, on the industrial design. Even though you had industrial design on this product, it was like against mainstream.
So alien looking. So alien. Yeah.
And then this maybe was a major turn down for some people. But putting all this aside, would you say that the better fork is a linkage fork?
I would say that it has its compromises. I think that I fully believe in the product, in the potential for that trust product. I think that the biggest challenge is human nature and trying to cater to that learned body memory and human nature itself. And that's probably the biggest, that's the hardest thing to make that product work. I think like adding hysteresis into the product had nothing to do with performance. It just literally had to was going towards making it feel more like a telescopic fork. So it was a lower barrier to entry for more people to, ride it. Like it's there are certainly compromises that go in a different direction, but there's certainly more potential. But, you got to keep in mind with the telescopic fork, we have, 50 years of learned experience as an industry, mountain bikes, motorcycles, that have really kind of refined these things. There's been a lot of people that have worked in the companies that have done this stuff, and that knowledge has matriculated across the industries, different companies, motorsport to bicycle to whatever, There's a lot of brilliant people that have worked really hard to make those things be able to even go up and down. And if you think of like, hell, think of like a moped fork back in the like early 80s or 90s and riding that thing compared to what our mountain bike forks are now. It's like a world of difference, right?
It rides like a bag of sand, I guess.
Yeah, exactly. So I think, I believe in that. I believe in the concept. I believe it can be executed. I don't know if people can truly, I don't know if the masses in the marketplace could truly wrap their brains around it fully. But, if given 20 years over time in a slow roll and kind of bringing people up to it and building that groundswell, I think it could get there. It's just it's funny, like, in my mind, Trust was never a mountain bike fork company. And certainly there were other things that we built and that we're, working on that were what I viewed the future of that company. But early on, I brought in so many mountain bikers that was really what everybody cared about the most. And, we kind of ended up probably pushing that too hard. And, not pushing in other areas soon enough. And that kind of, that coupled with a couple other issues just really made it hard. The bottom line is with that company, I mean, it's so hard. People don't understand how difficult it is to build a suspension company. Like, I think in people's minds, it's like somehow equivalent to a bike company. It's not. It's orders of magnitude more difficult. The level of back-end systems, the level of the level of complexity you need on drawings, prints, quality control. Like, we had our own full metrology lab, like a full lab. Like, we needed it. It wasn't like something we wanted and we was, it's super cool because we have this metrology lab. Like, we couldn't build what we needed to build without it. We had tools in there that most bike companies never even know exist. Every part of it, it's just so much more difficult. It's until you do it, it's hard to really appreciate the level of challenge. And I think like those are the things we did really freaking well. things that we screwed up were the easy ones.
The thing is, in the end, it's like you have a product. Nobody knows what's behind it and how much effort it actually took to get to that point. And then you have like product A and product B. And you have a product manager at a bicycle brand making a decision on the reputation of the product. So yep. What would you do if you would be walking in these shoes? Like, you either you're going with the product A, which is known in the market, and people or media had positive reviews, and it's well known for functioning, maybe to let's say 80%. And there's a different product, looking different, gaining 20% of performance, but you would go up against what is known or the status quo in the media, in the product management, in the market. So there's no way you're going to win unless, and also, let me add to that, the 20% of performance gain would be achieved by a better R&D, more cost, as you said. You set up a complete lab. And then this product wouldn't be as competitive price-wise on an OE level. Means there's a no-brainer to go with a traditional product. You can't go against this, even though you have the better product.
Yeah, and I mean, I think better is subjective, right? I don't know that. I think the telescopic forks are very good and they function really well. I would say on the price side, we could have been, and I had intended on us being significantly, almost half the price. But we got really high. Our group of leaders got really high on our own supply of how the performance of those products out of the gate, especially when we started measuring performance and measuring, putting capable riders on it and measuring times and saying like, holy shit, it's literally freaking 10% faster. Like, that's ridiculous. Like, and that caused some pretty bold, we needed funding, we needed capital. So, going out of the gate with a higher price than we initially intended. I mean, I think it was supposed to be $1,400 out of the gate, which is more than a telescopic at the time, but not that much more. And we ended up selling for way higher than that until we sold the first 1,000, and then we finally, reduced the price to where we're closer to where we wanted to be originally. But I'll say, we had some amazing support from members of the bike industry, from product managers at different bike companies. There were so many that took a leap and tried it, and some loved it, and some weren't able to get their heads wrapped around it. And I think that's that's human nature, and that's fine. I mean, that's the same thing. Like I look at, like, it's so funny. Like I just saw that, obviously the new, the 4-bar Santa Cruz bike, right? And I think it's funny, like kind of people, there's a limit of what you can do with the VPP system. Like there are certain leverage ratios that you just can't achieve. Like would love to, you're never going to be able to do it. Can't do it. Like, and they've worked for years and years and years to try to get further away from that wallowy mid-stroke kind of, dead noodle kind of feel. And, I think like it's the same kind of thing, like that there's a certain part of the marketplace that like, your product can kind of fit. And, there's a certain part that, sometimes you just can't achieve. And I think with the Trust product, it was like that, there's a certain part of the marketplace that we were able to hit and, reward and that loved it. And I think there's a certain part of the marketplace that just kind of can't get there. Like you can't make it feel like a telescopic fork. Can't do it. Just like you really can't make a VPP feel like it's going to support you in the corner under, when you're hammering through a berm. Like you just can't do it. Unless you're adding a bunch of extra links and shit, but like under a standard 4-bar layout, you just can't get there with that layout. It's not a knock on the design. It does some great things. And I learned a lot from riding those bikes. And, I've certainly, used things that I've learned from riding those products to like change characteristics of products that I've worked on, one way or another. Right. But it's not a knock. It's just reality is what it is.
So when companies, we dipped on that topic earlier, when companies approach you and say, we want to build a bike, how do you decide the behavior of the kinematics?
Well, first off, like I'll say that for the last 10 years, maybe even longer, I've said no to everybody who's come, largely out of respect for where Pivot and Ibis are. Obviously Turner Bikes was the one of the three that when we started out, Turner had the most momentum. They were certainly the largest, the most established, and for the first few years sold the most product by a lot. That was, and I would say I had moved away from Iron Horse right when I agreed to work with, those guys. So, I mean, I've only just recently started saying yes to new brands, in the last couple of years. And for me, it's simple. Ride with the people, see how they ride, try to understand what they're doing and what they like, and then, oh shit.
There's some aftermath of Hurricane Helene, got cut off electricity. So this is the first part of this episode, and we will record part 2 soon. Subscribe to this channel to not miss the future episodes.